Here we have the 2008 oblique collisions question. We have A moving in this direction, the angle of 45, speed of u. So we have my vector is u cos A, u cos 45 in the I direction, plus u sine 45 in the j direction. So its velocity before impact is just going to be u over root 2 in the I direction, plus u over root 2 in the j direction. Set up our table. An identical smooth sphere B, so we have M and M, which is at rest. So 0 in the I plus 0 in the j. So there's no change in the I here, or in the j, so we have pi plus u over 2 root 2 in the j, and we have qi plus 0 in the j. And we're told the coefficient of restitution is e, and show the direction of motion of A is deflected through an angle alpha, where tan alpha is equal to 1 plus e over 3 minus e. Okay, so it's deflected in this direction somehow. Let's have a look at what's going on. So we're going to have conservation of momentum m by u over root 2 plus m times 0, if you want to put it in, is equal to mp plus mq. So we're going to get p plus q is equal to u over root 2. We're also going to have p minus q over u over root 2 minus 0 is equal to minus e. So over u over root 2 is equal to minus e. If you want to write like this first, so p minus q is equal to minus e u over root 2. And we also have p plus q is equal to u over root 2. So combining these two things, we're going to get 2p is equal to u over root 2 minus eu over root 2. So p will be equal to u over 2 root 2 minus eu over 2 root 2. So the angle of deflection, we can say, when we get my vector now, I'll put the p in and I'll bring in the u here. So my vector now for, did I call these A and B, or A and B? A and B, we should have labeled them, A and B. So we're looking at A. We now have P, which is u over 2 root 2 minus EU over 2 root 2 in the I direction, plus u over root 2 in the j direction. And we can say the tan of the angle here, call the angle C maybe, because we use A and B, is equal to u over root 2 divided by, well, I'm going to simplify this as I go, create one fraction, cross multiply 2 root 2 times u minus EU by 2 root 2, so minus 2 root 2 EU all over 2 root 2 by itself, which is going to be 8. So I turn this fraction upside down and multiply. Therefore, I'm going to get 8u on top, and on the bottom, I'm going to get this root 2 by these two things. So if I do that in one step, root 2 by 2 root 2 by u is 2 by 2, 4u minus 4eu. So that's the tan of my angle. The u's I can divide by now. So I'm going to get 8 over 4 times 1 minus e, which is 2 over 1 minus e. This is the tan of the angle. We're asked to show that the motion, the direction of motion, is 1 plus e over 3 minus e. So we look here, the angle of deflection is going to be the alpha plus the 45. So let's have a look at tan of A plus 45. Tan of A plus 45 is tan A plus B, which is tan A minus tan B, all over 1 plus tan A tan B. signs in the wrong order. It's tan plus, I'm doing the minus one, so it's 1 minus. So we're going to have tan A minus 1. From here we're going to have tan A plus 1, tan A plus 1 over 1 minus tan A by 1, so 1 minus tan A. That then has to be equal to what we got above here, this 2 over 1 minus E. So we cross multiply, we're going to get 2 minus 2 tan A is equal to, I'll multiply the 1 by tan A plus 1 first, so tan A plus 1, and then minus E by tan A, and minus E by 1. So what can I do? I can factor on my left, I can factor, when I bring my tan A's together here, I'll bring 2 tan A to the right, add it to tan A to get 3 tan A, and I have minus E tan A also over there. And I've left 2 over here, and I'm bringing across that E, so plus E. So that's equal to tan A by 3 minus E, that 2 plus E. So hopefully they're looking for tan A to be 2 plus E over 3 minus E. 1 plus E over 3 minus E. What have I done here? Should be 1 plus E. I've left out this 1 as well here, look. So that's going to be 1. 1 here, 1 here. 1, 1. And you can see your mistake here when you get down to the end, so nothing to panic about. 1 plus E over 3 minus E. Got there eventually.